Hello guys, welcome back to another lecture in this course. In this video, we shall be looking into supervised learning algorithms. And our first supervised learning algorithm that we are going to look into is linear regression. So linear regression is a statistical method used to check the relationship between two or more variables. And these variables are independent variables and dependent variables. So we use the independent variable to predict the dependent variable. And we use the following formula in linear regression: y equal to mx plus c, or f of x equals to xb plus c. So this is the function for our linear regression model, which actually gives us a linear programming line, and where y is the dependent variable. Y is depending with the mx plus c, and x is the independent variable. It is a variable which is not depending on anything. M is the slope or the gradient of the line, or M is the line which actually gives us the relationship between the independent and the dependent variable. C is the y-intercept of the line. Where the line cuts across the x-axis is where we find C, or the constant. And remember, the line only cuts across the y-axis when x is equals to 0. Now let us take a look. Let us dive into our supervised learning algorithm of linear regression. What we need first is to import pandas so that we'll be able to read files like CSV files, and we also need to import NumPy since we are dealing with the numbers, or we need to manipulate numbers. And also we need to plot graphs. So to visualize graphs well, we need to import matplotlib.pyplot as plt. And also we need to deal with the linear regression, and linear means a line. So we need the linear regression, and this linear regression, we are going to take it from our linear model from scikit-learn. And also our model, we need to test and train our model. So we need to import the train test split from our model selection inside the scikit-learn. Now what we need to do, we're going to take a sample of a data set from housing. So we need to take a look into a housing data set. How are the houses given the prices? Is the price for the houses depend with the bedroom, depend with the date it was constructed? Is it depending on the location? Is it near to the town? Is it far? Is it because it has 10 rooms, it has underground? We need to see. So what we need to do, we need to import a data set. And this data set, you just go here, and I've already attached this data set on this course. So we just download it and you can proceed. And also the code, I've also attached the code there. So what we need to do, for example, in this case, we're just saying we paste it right here, and make sure you remove this and put this backward slash. Same goes here, we put backward slash, and same goes here. So now what we need to do, we create a variable and we call our pandas data frame, and we need to read our CSV file here of housing. And also if you want to see how many rows and columns that we are having, we can just run our code here. Let us run. Okay then, so after running the following line of code, we can actually see that we have 21,613 rows and 21 columns. So these 21,613 rows, these are our observations, and also we are having 21 columns, which is our attributes. Let us say dot head, so that we can only see five rows. Okay, then we have 5 rows and 21 columns. So this is the ID, this is the date, this is the price. So we can actually see, we want to analyze that price. We are going to assign price as our dependent variable. Is the pricing of these houses depend with the number of bedrooms, or is it depending with the number of bathrooms, or is this depending with the number of square feet of the living room? Or the pricing, is it depending with the floors, the waterfront, with the view, or is it depending with the ratings, or is it depending with the basement? So these are just attributes or variables which are contributing to the pricing of the house, so of the housing. So we are going to use supervised learning to analyze this data set to see how the pricing is being determined of these houses. So what we need to do, we need now to split the data set into training data set or into training data. So we have to pick our variable. So this variable, we are going to call it bedrooms. So we want to see if the pricing is determined by the number of bedrooms. So how to fetch the data? Remember, this is our data set, housing underscore data set, then square bracket, then our variables, they are always in a list. So we have 21 features. So we need only this feature, the bedrooms, and we are going to analyze the bedrooms against the price, where price is our y, our dependent variable, which is y. So here now we are creating our x train, our x test, y train, y test equals to train underscore test underscore split. So we are splitting our test based on x and y, where this is our independent variable and this is our dependent variable, and our test size there, we are putting our test size as 0.2. That's our test size. Now, after determining the test size, we need to create a linear regression model. So since we have already imported the linear regression model, we have imported it from our linear model here. So we need to put this in a variable. So this variable, we are going to name it linear regression. So this is the variable that we created. It's linear regression. Then we store our linear regression in this variable. Now we need to fit the model to the training data. Since we have trained our data here, we need to make sure that we fit our model on the line. So our line, we are saying linear regression dot fit x train and the y train data. Now what we need to do is to predict the housing price for the trained data set. So to predict it, we need to call the dependent variable. So meaning we call the dependent test. After training, we call the dependent test data. So the tested data will give us a prediction on whether it is accurate, that it is true that the price of the housing is determined by the bedroom. So finally, now what we do, the model evaluation, we are going to use mean squared error. So let us run our code. So mean squared error, it is simple. We just call our numpy.mean, then our dependent underscore prediction here. So we say dependent underscore prediction minus our y test power 2. Okay, since it is our mean squared error times 2. Then we run this line of code. Now we get 1.12468, which is a very large number. So here we can actually see that the predicted price and the actual price is very large. So this model, the mean squared error, is not very accurate at predicting the price of houses based on the number of bedrooms. As we can see, we are actually seeing that it is the mean squared error had failed. So in short, we can say that the mean squared error can be interpreted as the average squared difference between the predicted values and the actual values. And this means that the price are very far off from the actual price. There's a huge difference. So one of the reasons is that there is no a linear relationship between the two, the price and the bedrooms. And the number of bedrooms is not the only factor that affects the price of the house. As you can see here on our data set, we have 21 columns, meaning 21 attributes or factors. So probably maybe the living square room, the living square feet is contributing to the pricing, or we can say maybe it is the basement. Maybe it is the basement which is contributing to the pricing of the house. But the bottom line, we can say that it might be the location of the house and the size of the house and even the condition of the house. That's why you can see here on our data set, we are having a year renovated. As you can see here, we have here renovated, and we have the latitude and the longitude, as you can see. So there are a lot of factors which are contributing to the pricing of this house. That's why there is no any linear regression there. And if we are to go forward to actually check the relationship between the two, we can plot a graph. Let us plot a graph to actually see using a visual interpretation. We're going to plot a scatter plot. In the scatter plot, we're going to use our X train and our Y train, and we are going to make sure that we put in a color blue, our train data. And also, we are going to make sure that our coefficient value is there. So what we need to do on the x-axis, we're going to put bedrooms, and the y-axis we're going to put the prices, since on the y-axis is where our dependent variable is, and this is our independent variable. So let us run our line of code here. Right, as you can see here on our linear regression model, you can actually see that there is no any linear combination between this data, since our data is not well aligned with our linear regression line here. The data is actually reflecting that there is no correlationship between the bedrooms and the pricing. And also it can be explained using our statistics model here. So we can also explain the statistics model formula by using the ordinary list square here. So if you are to use the ordinary list square here, we have to import it from we have to use the statistics model formula here. So what you need to do, you open the bracket and you put the independent variable, the dependent variable and the independent variable. It's where we are doing our analysis, and the data set, which is the housing, and the data set dot fit, which we are going to take a look into, in which we are analyzing, and we have to take a look into a summary here. So let us visualize the output of our data. And we are going to actually receive the same result, that there is no linear regression, or there's no relationship between the two, the price and the bedrooms. Okay, so how to interpret the ordinary list square? How we interpret it? For example, let us start here with our deep dot variable here. When we say deep dot variable, we are saying dependent variable. And our dependent variable, we said it is a price. Price is depending with the bedroom. Okay, so that's what it means there. And also the model that we use OLS, which is ordinary list square. This one, the method is just say the method is the list square, and the list square is a standard approach in a regression analysis to approximate the solution by minimizing the sum of the squares of the residuals. And these are just the date where we perform the analysis. And also here is just simple, it is representing the number of observation, the total number of observation present in the data. And here the DF residuals, this is just the sample size. And remember, the sample size is the number of parameters being estimated. So in other words, we can say the sample size estimated is equals to residual equals to number of observation minus k plus 1. And where k, obviously, k for our parameter, we can say k equals to 1. So if k is 1, we add 1 plus 1. So number of observation minus k plus 1. So it's like a number of observation minus 2. That's why you are seeing the number of residuals is 21,611 here, meaning we have subtracted 2 here. And also, if you are to take a look into R squared here. So R squared is the statistics that will give some of information about the goodness of fit of the model. It gives us the goodness of the fitness, if the model is fitting or not. It ranges between 0 and 1. That's why we are seeing 0.095 here. And in our case here, we can actually see that our R squared is 0.0995, in which explains that there is a 9% accuracy in our data. So this is just a brief overview on what is being represented by this. We have F statistics and probability, here, this F value probability F is just a statistics test the overall significance of the regression model. So there are a lot of things that we can explain. We can see the y-intercept or the intercept, the bedrooms, the coefficient, the standard. There are a lot of things that you can decipher on this output here. Let us take a look into a linear regression model where the linear regression actually fits. For example, we are having this data set of student performance on a school. Here I just only run an output of 5 observations on my CSV file here. We can actually see that we want to see if the performance of the students in mathematics here, it is relating to reading, writing, and so we want to see the performance of the math score is based on reading and writing, or it is depending on the test preparation for the students. It depends also in whether the kid is getting lunch or not, and the lunch is it standard, is it free, is it reduced, or it depends with the parental level of education. Does the parent have a degree? If the parent is having a degree or attended a degree, does the performance has to do with the parental level or the ethnicity group, or is the parenting has to do with the gender? So we just want to take an analysis on the mathematics score based on the variables that we are having. So the best way to analyze this data, we are going to check to make X our independent variable, writing skill. We want to analyze it with the math score, which is our dependent variable. So if the student is able to write, he should be able to get also at least a good score in math. Then we are going to train our data here, and our test size is going to be 0.1. And from our skitline, what we need our linear model so that we can call our linear regression here. And after our regression model, after creating our regression model, we need to fit it here with X train and Y train, as you can see here. And last thing that we can do is to plot our regression model for the student results. So let us run our line of code, as you can see. Right, we can actually see that this data is fitting in on our linear regression, meaning that the math score, which is our dependent variable, it is actually depending with the reading score. So there is a linear relationship, or there is a co-relationship between the two, the math score and the reading score. So if we are to check the reading score, not the writing score, let us check the reading score. Let us check the reading score. Okay. So now let us check. We are checking now the relationship with the writing score, reading score. We can also still see that there is a linear relationship between the reading score, the writing score. They are all contributing variables to the mathematics score. I think this is all for this lesson. Thank you for watching. See you on the next lesson. Bye-bye.